understand about the topic registers. What is a register? A register is nothing but a collection of flip-flops. It is a collection of flip-flops which is cascaded is called as register. Generally, these types of registers are used to store the data in digital system. For example, if a 4-bit register can store binary bits from 0000 to 1111, these are called as contents or the states of the registers. Now, under registers, we will be today understanding about shift registers. As the name indicates, shift. What are the shift registers? These shift registers are capable of moving data which is stored in their flip-flops in either direction, in one or two directions. Generally there are two types of shift registers. One we call as unidirectional, that is one direction. Unidirectional shift registers. The other one is bidirectional shift registers. Two types. Generally, unidirectional shift registers, these can shift data as the name indicates in only one direction. When we call as bidirectional shift registers, can shift data in both the directions. These bidirections are again classified into four types. One is serial in, serial out, serial in, serial out. We also call this as SISO in the short forms, that is serial in, serial out. Second one is serial in, parallel out, that is serial in, PO, parallel out. Then third one, parallel in, serial out. And the fourth one, parallel in, parallel out. In detail, let us study about one of the shift registers. Four. So let us study about the first one, that is serial in, serial out, unidirectional shift registers. So as the diagram is indicated here, this is 4-bit shift registers because you have 4 D flip-flops connected together, as you can see. So this is your serial input data. This is the clock pulse. The clock pulse is cascaded to all the 4 flip-flops mentioned as A, B, C, D. So we have used 4 D flip-flops. You can see here DA as the input and QA bar as the outputs. But the other end is left out because only one output we are shifting at a time. So here the D inputs of each flip-flop, as you can observe, is connected to the Q output of the previous stage, where to the left when a clock pulse is applied to the C input of the flip-flop A. Here the data on the serial in line gets stored in the flip-flop A, initially here A, and appears at QA here. So every bit it is shifted one position to the right. Now the serial input is shifted into flip-flop A, and the contents of flip-flop D here, the last one, gets out and is lost. So let us consider an example in order to analyze. Let us take the value 1010. So this is needed to be stored in, serial out register. Then what it has to do? It should be serial in, serial out means one by one. It has to given as the input one by one. It has to be taken as the output. Now we have indicated here as serial in. You can see in the truth table the serial in. What is the value taken? 0101, or from this side 1010. That is the value we have taken, 1010. The rest of the values we have taken as don't cares. We have taken the clock pulse. Now initially, as we studied from the circuit diagram, the first value, that is 0, is entered into the QA, or least significant bit, most significant bit. You can just observe here the way you enter. If you enter 1, the 1 is stored here, next 0 is stored, next 1 is stored, next 0 is stored. Then slowly it is shifted. You can observe here, this 0 is shifted here, this 1 is shifted here, this 0 and 1. So you can observe again, each case it is shifting. Now initial it will become 0. Then what we have entered, if most significant is 1, the most significant is exited outside from the QD serial output port. So what is the output here? Again we'll get 1010 as our output. So what we mean to say is that data is fed serially and the data is obtained back serially here. So this is the overall concept of serial in, serial out flip-flops. Similar lines, we will also be able to obtain the data in serial in, parallel out. The only difference in serial in, parallel out is if you give the data 1010 in the serial input, the data will be stored one by one, but the output can be obtained as 1010 from 4 flip-flops simultaneously. That is, QA will display 1, QB will display 0, QCD will display 1, and QD will be displaying 0. Similarly, the other shift registers. So hope you understood. Thank you.